Okay, hi. So today's lecture is going to be about bashing. Okay, so bashing in geometry. Um, I mean, if someone doesn't know me, then I am Rijul. So Rijul Saini. Okay. You can. I'm a past IMO silver medalist. Okay. Since then, I've done my BSc at CMI, and then subsequently PhD at TIFR. Can reach me at Discord. Okay, so Alish Allen. So this is my Discord ID, and my email ID is saini.rijul at gmail.com. Okay, so today we'll be talking about um, bashing in geometry. So the first one I would like to start by is my favorite one, which is trig bashing. Okay. So this is like works well. Sorry. Okay, so it works well if there are bunch of lengths and angles, okay, in terms of which one can write everything, okay. So the like what is the complexity, right? So in every bash there is a complexity of the bash, okay, and the complexity will depend on the number of length variables and angle variables. Okay, so usually a reference triangles, side lengths and angles are nice to work with, okay. Okay, why? Because mainly because that is like the most practice that one can have, right? So like usually all the formulae and stuff like that, okay, they work nicely in terms of angles, side lengths of a triangle and angles of those, okay.
I'd presume that this sort of bashing also goes hand in hand with like Siva and Menelaus and all that.
Yeah, of course, okay. So because this is the like, quote unquote practiced kind of bashing, okay. So what's an example of a trig bash? Okay. So okay, so yeah, so most powerful techniques here are trig keva. Okay, so that's like the most powerful technique that you have. And then, of course, cosine rule and sine rule are your friends. Okay, so these are the main techniques. Okay, but then trig keva is like the nice thing here. Okay, so for example, you can solve like a bunch of. Okay, so in principle, one can write down everything using like sine and cos and lengths. Okay, but in practice, of course, you need to consider how complex the calculation will get. Okay, so as a very simple example, like you can, for example, consider any RMO geometry. Okay, so yeah, so for example, this year's RMO paper. Okay, if I like pull that up, let's say,
P3
yeah,
this year was just screaming for
yeah,
trig bash.
yeah. So for example, that one. Um, yeah. So for example, this P3 right here, right? Yeah, I don't know what. Okay, so whatever. The point is that oh, why is this not working? Anyway, I can also just have it transpose. Okay, right. So let's look at this question. So how would you trick bash it? Like I'm sure a lot of you have done it in the in this year's paper already. Yeah, can someone answer?
We have isosceles and we have the side lengths equal. So like the side lengths and two angles are nice. And then
Mm-hmm.
OD is a pretty much known formula, and so is
Yeah,
HD.
yeah, of course. Okay, so you have like um O here, some H here, something like that. Okay, G here. So OD is well known to be R cos A. Okay, HD is 2R
Where,
cos
where do
B
you
cos C.
where,
Okay,
how do you see this? Where is this? Where
what?
can I read this sort of stuff?
You can
ODS.
derive this. I mean, it's not hard to prove. You can read it in, for example, Challenge and Thrill, you can read it. So, okay,
Cos B
so
to cos B.
Yeah, so OD is R cos A, HD is 2R cos B
Like
cos C.
in our context, cos B is equal to cos C, right?
Right. So I'm
Okay.
going to do that. Okay, but like I'm just telling you the general formula. Okay.
What would be the outline of the proof for the formula? Second one.
Second one,
Yeah, the outline of the proof.
I mean, BH is
Oh yes, yeah, I got it.
2R cos B, if you know that proof. But
Yeah, yeah,
if
yeah.
you don't know, then it's okay. Well, so okay, I'm just not going to go over it. It's not hard to prove. Okay, like I can do it in 2 minutes, but I don't think I have that 2 minutes. So so HD is 2R cos B cos C, OD is R cos A. Okay, and B is equal to C. Okay, and it's equal to let's say 90 minus A by 2. Okay, so therefore you have 2R sine square A by 2. Okay, and so this tells you something like cos A equal to 1 by 5 or something, or cos A by 2 is 1 by 5, something you get. Okay, so like
Basically, you just get a quadratic in sine A by 2.
yeah. So I mean, so you get cos A, I'm pretty sure. So what is this? This is R into 1 1 minus cos A, right? Yeah. So then you have 23 minus 23 cos A is equal to 2 cos A. Okay, yeah. So you get cos A is 23 by 25. Okay. And correspondingly you get sine A is what is it? 625 minus 29. Uh,
131 over 625.
yeah, no, there's something wrong, I think. That's fine. 23 times HD, 23 minus 20. Okay, and then what do you want, right? What you want is you want
You want GD equal to twice the
I,
radius.
exactly. So you want AI, yeah, so you want ID equal to see, AG is to GD is 2 is to 1, right? So you want AI is to ID to be so this is the question mark and should be, so this is 1 by 2. So you want it to be 5 is to 1, right? So you want this to be 5. Okay. But AI is equal to R by sine A by 2 or something, right? So therefore AI by ID is equal to 1 over sine A by 2. Okay, and sine A by 2 I'm sure is 1 by 5 or whatever. Okay, so this is 5. Okay, and AI is R by sine A by 2 is quite easy to see. Is it R by, yeah, that's correct, right? Okay, and ID is R. Is this understood? Okay, so this is
Yes.
1 minus 2 sine square A by 2. So this implies sine square A by 2 is 1 by 25. So sine square A by 2 is 1 by 5. Okay, please tell me if there's any doubts here. Well, we never use that, right? We never use the fact that O, G, and H are in this order or something. right? I just use the fact that OD and HD have this ratio to prove that sine A by 2 has to be 1 by 5. And then I just use the fact that A, G, and I and D are collinear. And so it will suffice to prove that AI is 5 times ID. Okay, because that will prove that AI is to ID is, I mean, you can just now you can just see it, right? Like if AD is equal to 6, okay, AD is equal to 6, then I will occur like at the 5-unit distance, right, from A. But then G will occur because AD is 6 and it divides it into 2:1. So AG will be 4, right? So that means GI is 1. Okay, so which means that GI equal to ID, equal to the radius. Is that understood?
Yep.
Okay, so that's like one exercise with like usual trigonometry. Okay, but like for example, if you look at the other RMO problem, okay, there also you can apply trigonometry. Okay, okay, so any idea for this one?
Is it fine if I just make a diagram?
Yeah.
Wait, why did they not just write that L is the midpoint of AD? Why phrase it in such a complicated way?
It's fine.
My first thoughts, like excluding any bash ideas, is
Mhm.
introduce the midpoint of BC as well, because
Yeah.
then we get the AB plus CD quantity to be
Mm.
twice of L prime if I let that other point be L prime.
Yeah, exactly. So that is the synthetic proof idea. So you just prove that OLK is similar to OAC, and that will be the proof. Okay, like that's the one-line proof. We'll follow directly from this.
How do you prove that OLK is similar to OAC?
Because OLK is isosceles, right? OL is equal to OK because AD and BC are equal chords, right?
Yeah. Yeah.
And OAC is also isosceles. OA is equal to OC, right?
Yeah.
So it
Oh,
suffices to just show that the angles are equal. Okay.
yeah, you got it.
But then angle this is equal to angle this. So just add this to both of these angles. Yeah, however you want to look at it. Okay, so anyways, but that is the smart way to do it. Okay. Today we are not like, okay, we are trying to be smart, but like we're not trying to, be overly smart, let's say. Okay. Trying to restrict our smartness. So
We can just compute OL because we can just assume ACD to be
Yeah,
something.
exactly. So
And
so we
then
can, so our reference, I talked about a reference triangle, right? So usually a reference triangle, side lengths and lengths are nice to work with. Okay. So here our reference triangle, for example, could be ACD. Okay. Because once you fix ACD, B is defined, right? Like uniquely determined. Okay. So let's say I make triangle ACD as my reference triangle, right? So then OL is equal to, so I'll call this C, call this A, and I'll call this D. Okay. So OL will be R cos C, right? Okay. Then OB is equal to R, of course, right? AC plus BD is 2AC, which is equal to 2D, right?
Yes.
So the main thing to now think about is what is AB plus CD, right? So mainly what is AB, right? Therefore, need to determine what AB is, right? Okay, but AB you can determine using sine rule, right? Because the point is that you can determine what this angle should be. So what should be this angle?
D minus C.
D minus C. Okay.
Yeah. So let everyone catch up.
Or you can, like, as Riddhiman has pointed out in the chat, and I was thinking, you can
So you
work
can do
backwards to
that
like
also.
find it and then.
Yes, yes. So that is also a powerful technique, that you work backwards and reduce it to proving that AB is something, and then you, I mean, but you still need some idea to compute AB, right?
Yeah, but like once you see the expression, it might help you a bit.
That's true. That is very true. Okay, but anyway, here AB can be determined using sine rule. Okay, so this is D minus C. So AB is R sine 2R sine D minus C. Okay, so therefore, enough to show that um, 2R sine D minus C plus CD. CD is 2R sine A. Okay, and then into OB into R is equal to R cos C into 2D. Okay, D also I can write as 2R cos D. Sorry, sine. Okay, so 2R gets cancelled, R gets cancelled. So it's equivalent to show that sine A plus sine D minus C is equal to 2 sine D cos C. Okay, but this
But
is
now we
clear
can write
because
A as like pi
realize
minus D
sine
minus C.
C plus D. Yeah. Okay, and then you can just expand it a little. Okay, so this is clear. Right? So such problems, like, so you have to realize what the how many lengths and angles you'll need to fix. Okay, so usually if you can get away with just fixing a reference triangle, that is usually the best. Okay, that is the best case scenario, because like if you have practiced enough, then you'll have worked with the triangle enough that you'll like naturally recognize what kind of things work and what kind of things don't work. Okay, so as always in mathematics, obviously practice makes perfect. Okay, now let me tell you a hard example of a trig bash. Okay, so that was this year's APMOP 5. Okay, so this is APMO P5. So it's a P5, supposed to be the hardest problem on the test. Okay, but I mean, there were other problems which were harder than this on, on this particular test.
I feel like we could somehow use manual loss over here.
Yeah, just try it for a while.
There seem to be a lot of like Mikhail points in the diagram, and like based on this diagram, it looks like X might be the Mikhail point of ABCD. I'm not sure if that's true or not.
No, that's
Rather, N looks like a Miguel point.
yeah. M and N are definitely Mikkel points or something, but
I think then you could do an angle chase or something.
yeah, angle chasing is possible.
Okay, introducing the Mikhail point of ABCD is still quite nice, I think, because
Mm-hmm.
like you have circles which are in one Mikhail quad but are also in another Mikhail quad. And then angle
Right.
chasing becomes a lot like more doable, I think.
Mm-hmm.
I haven't seen like anything about this problem yet. Like even in the contest, I ignored it. So
What was definition? Point again.
So definition of Mikkel point is like if you have a config like this, okay, then this circle, then this circle, like they're all supposed to be passing through a single point. Okay.
and then the interesting thing is if your original quad is cyclic, then this Mikhail point lies on the line between the two extensions.
Hmm.
I know it's a bash class, but MNQP also seems to be cyclic because we already have the top point on two of the radical axes. X is on the radical axis of the green circles and the
M
purple.
and QP seem to be cyclic.
Yes.
Okay.
If we could only prove that it lies on the radical axis or some clever other thing.
Yeah, you get that cyclicity from angle chase.
Mhm.
Sum of angles.
Okay.
I mean, interestingly, you can prove cyclicity using trigonometry if you want to. Like, you can take power of point with respect to some intersection, and you can compute those lengths using trig. Like, I literally just did this today morning.
Yeah, but how do you prove that M and QP is cyclic?
I am not sure how it applies here, but
Mm-hmm.
I was just stating a more general thing where you could use bash to prove cyclicity.
Yeah, that's okay.
No, you can prove that MNQP is cyclic.
Mm-hmm. How?
Like NMP is going to be equal to SMP plus NMS.
Mm-hmm.
And then you can get SAP is equal to SRN.
NMP is NMS plus SMP. Yes.
And then similarly, you can go and say that DAB is equal to DAB plus QRN is the same.
No. So what do you do with NMS and SMP?
No, like this is going to be equal. Wait, NMS and SMP. Wait, no, I said, yeah, okay, so that's equal to PAS plus wait, where is that? SRN.
PAS. Yeah, sure. This is PAS. And then
SRN.
SRM.
SRN.
SRN.
How?
What?
Don't see it.
Directed angles, I think.
Yeah.
Wait. Are we using directed angles?
No, I
Yeah,
mean,
Still, how are they cyclic?
using directed angles, like because we using cyclic quadratics.
No, but why
it
are
is cyclic.
MSRN cyclic though?
Which one? Which
Why
call?
is MSRN cyclic? I don't see that.
MSRN, MSR is
No,
equal to
MSRN. I didn't get that either. MSRN.
Oh, NMS, you said. So what are you doing with NMS?
So like you can use since CRNQ, SAMP and ABCD are all cyclic, right?
Yes.
So using that you can say
What?
by the similar triangle. At least that's what I got.
Yeah,
Maybe
just explain it, right?
no, maybe there's a mistake now. I'm not quite sure about the answer. I think I have to look through what I mean. Because I somehow I use the directed angles from there.
What did we do after the second step? I did not get NMS plus
Yeah,
SMP is equal
SMP
to,
is PAS. That's fine.
yes, because those are cyclic pattern.
Yes.
We don't have anything with NMS, I think.
Hmm.
Can we do some sort of projective here? Because it's
Yeah,
all
lots
defined at
of
intersection.
different things are possible, but not all of them work. I'll tell you that much.
I think I have a proof for SRNM cycle.
SR?
NM.
Okay, sure.
So angle SMR
Mhm.
is equal to angle AMR minus AMS.
SMR is?
Angle AMR minus AMS. Minus AMS.
Not in my diagram at least. But okay.
Are angles directed here?
Oh, okay. Okay, in this case, I guess AMR plus AMS.
Okay, then?
Now AMR is equal to AP. Sorry. One second. One second. AMR is equal to
Which quadrilateral are we trying to prove cyclic again?
M and SR.
SMRN.
so like AMS is equal to APS. We know that.
Okay, M and SR.
Yeah, AMS is APS.
Yeah, and AMR was equal to ABR in my diagram. But
AMR is ABR.
no, in my diagram, my configuration is different.
So what you can try is, for example, AMR is PMR minus PMA. Is that given?
Yeah, and PMR is PBR.
PMR is PBR, yes.
And PMA is, I guess, ASR. ASR. PMA is ASR.
ASR. Okay, on the other hand, SNR will be what? CNS minus CNR, like QNS minus QNC.
CNS is just CDA, right? Like directedly.
How do we get the second thing in that step?
CNS is CDA. Why?
Like from a directed angles approach. Like technically it would be 180 minus, I think. Because
What?
wait, is it okay, wait, sorry, I'm confusing both of the green circles. My bad.
Yeah.
How do we get the second step, like CNS to QNS?
Oh, I'm still going there. Like so QNS minus QNC. Like, this is CNS, and then yeah. Yeah, it's just same as saying QNR.
Well, CNR is equal to CQR.
So QNS is 180 minus QD. And QNR is RCD.
Yeah, so SMR is, so I write it like PMR minus PMS, and PMR
Wait,
is
QNSD is cyclic, right? Just to confirm. Like
PCR. That's why. Huh?
QNSD is cyclic, right? So
QNSD is cyclic. Yes.
so then QNS is like 180 minus QDS, which should be 180 minus CDA then.
Could you repeat?
Because QNSD is cyclic, QNS is 180 minus QDS, or in other words, it's 180 degrees minus CDA.
Okay, right.
PMBR is cyclic, by the way, not PMBC. Okay, even though in the figure it looks like it's passing through C, but it should be passing through R. Okay, just FYI. Yeah, anyway, so okay, so you can try a bunch of these things. Okay, so turns out what you can do is you can try to figure out. Okay, so let me remember what the proof was.
Here for trig bash, are we supposed to prove like Lx plus xk equals Lk?
No, that's the
That
one.
would be terrible to compute.
So what was the thing? Um, Mhm.
Wait, what about the previous black circle which did around LMB? Like, what
Mhm.
is that for?
Yeah, when LMAB will be cyclic.
Okay, I see why.
You could also use a diagram from AOP.
Hmm.
Could save time.
Nah, it's okay. Mhm.
I just remembered that like
Mhm.
M and N would have like good complex coordinates, right? If we wanted to complex match this, because they are the center of the
Spirosymmetry.
yes, and then we
Yeah,
could
but
potentially calculate X and prove it is equally.
X will have like very, very terrible coordinates.
Yes, that is true.
So when you get x, okay, assuming we do a complex batch and somehow we get coordinates of x, then
Mm-hmm.
we would go about it by showing that k is a linear combination of, I mean, x is a linear combination of L and k, or is there some other way?
No, can you repeat?
Assuming we get the coordinates of x,
Mm-hmm.
would we go about showing that L, K, x and k are
Yeah,
collinear by,
collinearities are also not great in
I see.
complex. Yeah, something like that, yes. Like you'll have to show some kind of determinant being 0 or something. Yeah, complex collinearities are not great. Okay, so here's what kind of works, if I remember correctly. Okay, so what you do is you look at P, Q, K. Okay, so P, Q, Q, K, and P, K. Okay, so you want to prove that these lines Q, N, so that is emanating from Q, P, M, that is emanating from P. Okay, and K, L, that is emanating from K. Okay, that these three are concurrent. Okay,
Oh,
so
so
you
now you
apply
try to use trig Sava.
trig Keva, yeah. Okay, on triangle PQK. Okay, for the lines PM, QN, and KL. Okay, and so I'm not going to go into too much calculation here. Okay, but if I remember correctly, this works. Okay, so where you assume like this is theta or something, like you assume a bunch of angles. Okay, and you write it in terms of those angles, and this works. Okay, so like I said, I mean, it's a hard problem. Okay, it's not a very easy problem. Okay, there are other ways to do it, of course, but the way that I did it, like it took me quite a while. Like, it took me like 2 hours, I think, if I remember correctly. But then I ended up with having this solution. Okay. Also, I did it not in test, of course. Okay. I was looking at students do the test while I was doing it. Okay. So yeah. Yeah, so synthetic is like that is usually the case, right? Synthetic is nicer than bash. And yeah.
Synthetic
we
is
join?
like supposed to be harder
satisfaction.
to see than bash, and bash is supposed to be harder to compute than synthetic.
I would not say synthetic is easier than bash here. I don't think that is quite right. Also, inversion just does not work. Like you can try it, but
Inversion does not work. I thought inversion is easy and complex.
come again.
I thought inversion was easy and complex.
What do you mean inversion is easy in complex? Like
You said that
I'm just
inversion
saying
doesn't work.
inversion doesn't work. Like inverting the diagram doesn't work.
Oh, okay. I thought you meant that inversion doesn't work in
The
bash.
reason it doesn't work is because there are a lot of circles, but those circles are all in very different places, right?
Well,
We could invert
there are
around a
also a
Mikkel.
lot of lines is the main problem. Okay, it's not
Right,
just
that's
about
true.
the circle. Okay, being in different places. It's more like there are a lot of circles. That's true, but there are also a lot of lines. Okay, so
What
you
about B? We could invert around B. Most of the lines pass, many lines pass through B.
so
And
many
many
lines
circles
do
pass.
pass through B, but like
Yes.
for example, PM and QN don't pass through B. You know, like
Oh,
as
right. So now you have to deal with circle intersections, and then that gets
exactly.
messy.
Yeah. I mean, you can try. I mean, it might work. You could get some different solution. Okay, but I haven't seen any solution using inversion at least. Okay. All right. So again, I won't go into too many details. I'm already kind of running out of time. Okay. So let's discuss one very nice coordinate bash problem. Okay. Next. So okay. So actually, let's first discuss what about coordinate bashing. Okay. So okay, so let's talk about coordinate bashing. Okay, so obviously I'm talking about Cartesian coordinates. Okay. So what's the pros and cons, right? So most important pro is that if there is a prominent right angle, okay, this is the most useful. Okay. Usually.
What about vectors?
Okay.
What about
So
vectors?
yeah,
Vectors.
we'll discuss that maybe later. We're discussing Cartesian coordinates right now. Okay. So then if there are a bunch of perpendicular lines, okay, like usually this bash method is nicer than others. Okay. So bad with dealing with circle intersections. Okay. So circle intersections are just bad. Okay.
The reason is
So
that circles are bad and then you have to solve like bivariable quadratics.
so there are ways to get around it. Okay. So usually you try to get around it. Okay. By finding some other property of the point. Okay.
So maybe
What
we
about
can find
circle
the
line?
radical axis and then the intersection.
Yeah. So there are like
What
other
about circle line
there are ways
intersections?
around it. Okay. But usually you don't ever want to intersect two circles. Okay.
What about circle intersections?
Huh?
What about circle line intersections? Like if you have a circle and you have a line.
So circle line intersections are not bad. Okay. Because usually one point is usually known. Okay. And then you can use Vieta's formula to get the other point. Okay.
And why can't we do that for circle intersections?
Because then you have two quadratic equations with two variables, so it isn't as straightforward.
Not.
I mean, if you have one point and you have Vieta, you can't you figure out the second point quite?
I mean, in theory, yes, of course. But I mean, the whole point is that it will be much more messy. That's the point. Okay.
I didn't quite get the Vieta implication here exactly.
Because you'll get a quadratic, right?
From circle and line, yes.
And then one solution is known. So the other solution you
All
can.
right, then you can use. Okay, I see what.
Okay.
I mean, aren't two circles just a circle and a line? Like you can just subtract the circles to get a line, or does that not work?
I mean, again, yes, you can do that. And I mean, anyway, like I said, you try to get around it, right? So that's why you try to do the circle plus line instead, like you said, by subtracting and stuff. Okay. So you can, but you don't ever want to intersect circles as it is what I'm saying. Okay. Like don't try to write down equation of one circle and the other circle.
Yes.
Okay. All right. So, okay. So here also take some time to figure out best coordinates. Okay, like what do I mean by this is choice of origin. Okay, choice of x-axis and y-axis. Okay, so let me now discuss a very easily bashable problem. Okay, but the point is that if you choose the wrong origins, okay, it's much harder. Okay, but if you choose the right origin and the right x-axis, y-axis, it's way easier. So try this problem. So this is IMOTC 2023 practice test. 1.
Okay, so my first thoughts, if I just read the first few lines, like the first line-ish, is just let like D be the origin and BC be the x-axis. Because then even P and Q have nice coordinates and they lie on the x-axis as well. So
Yeah, so just think it through.
Yeah, this does sort of seem rational.
yeah, so another thing that's good about that setup is that I can use power of point and section formula to get x and y.
And we can set a is equal to 0, comma y, which will reduce the calculation.
Okay, yeah, this seems to be good now because I can just compute the intersection of the perpendicular bisector of PX and BC. I don't know how hard that is because I don't do a lot of bash. But assuming I compute it, its coordinates should be somewhat similar to the coordinates I obtained when I do it with QY and BC, and I can prove that they're the same point then, is my thought.
Can we add x and y also to the diagram?
So x will be like here somewhere, and y will be like. Okay, so D origin is BA, BC as x-axis, y-axis. Okay, so does anyone have a better setup than this? Okay, so there is a even better setup than this.
Maybe A as the origin and P and AQ as.
Yes. Okay. So that is the best setup.
Like we have a lot of lines coming from A, so it makes sense to make it the origin.
Exactly. Hey, not just that, it's more like the prominent right angle is not this, okay, but it's actually this.
Angle PAQ, yes. And 45, 45 as well. So
Right?
Yeah, so you can get the isosceles one.
Okay, so A origin and P and Q as 1, 0 and 0, 1. Okay. Or
D is half.
you can even take it to be 2. And
D is 1.
1, 1. Yeah. Okay.
Yeah.
So then X will be some
T comma 2 minus T and then
like let's say A, 0, Y is some B, 0.
oh right.
Right. Sorry, 0, B. Okay. And then B will be chosen so that PB into PQ is equal to PX into PA, right? So therefore, if B is equal to, let's say, what will it be?
T and 2 minus T.
Alpha comma 2 minus
2 T comma 2 minus T. Okay. Then you'll get that P, so A minus, you'll get that 2 into A minus 2. Sorry, 2 into 2 minus A.
2 minus A.
Is equal to whatever PB into P. Sorry, what? No. PB into PC. No. I think.
Yeah, we can do that.
Yeah, actually, you can just write down the equation of this circle, right? You have origin A. Just write down AXY circle, right?
X minus C by
I would
2.
take them to be 2a, 0 and 0, 2b. It will make the center better. We could take X to be 2a
Sure.
and
I mean, it won't matter too much, but yeah, sure.
X minus whole square plus
AXY will be
X minus
exactly. So the circumcenter will be then A comma B. So therefore it's just X square, X minus A whole square plus Y minus B whole square is equal to A square plus B square. Right? Okay, so therefore you just intersect this with X plus Y equal to like you just X plus Y equal to 2, right? Yeah. So you'll get something, right? Those are not hard to.
Yeah.
Okay, and then the perpendicular bisectors intersection, that will be nice, right? Because like PX perpendicular bisector intersection QY perpendicular bisector is going to be whatever A plus 1 comma B plus 1. Okay. So you just have to show that this point lies on the perpendicular bisector of
BC.
BC, right?
I don't think that's hard.
Actually, it's easy because you know that the circumcenter is A comma B, right? So all you need to show is that A comma B to A plus 1 comma B plus 1, this line is perpendicular to XY.
Wait, how did you go to the conclusion that the intersection is A plus 1, B plus 1?
I mean, that's easy because the x coordinate will have to be the average of the two. Y
Ah,
coordinate will have
yeah.
to be the average of the two,
Okay.
right? I mean, these are like A origin just makes it like so easy that it's unbelievable. Okay. D origin is still very doable. Okay. But it's a bit of work. Okay. But A origin is like, it's so smooth, it's unbelievable. Okay. So D origin is nice. Okay. But like when I checked this paper, okay, a lot of people took like B origin and C origin, and like it was horrible to see the
B
choice of
origin?
coordinates.
Did
Okay.
anybody do A origin?
Huh?
Did anybody do A origin?
Yeah, I think one or two people maybe. I don't quite remember.
How does that
I
work
guess
out?
some
What's
people
the
would have
synthetic
tried
solution?
Huh?
I
What's the
guess some
synthetic
people would have
solution?
tried a B origin thing. Someone would have tried a D origin thing also, maybe.
Haha, D origin many people tried, but
So that was the common one.
yeah, D origin is like natural to take, right? D origin is like you're not using your brain. Okay. But it's okay, Malav, it works out. It's not
What's the
that hard.
synthetic solution?
Huh?
The synthetic solution. What is that use?
Synthetic, okay, I don't quite recall right now. Like you can try it. Maybe after the class we can discuss. Okay. Anyway, so do you get the idea? Okay.
Yes.
Okay, so then let me tell you another problem that I bashed long ago. Okay, so this is IMO 2012 problem 5. Okay, so this is my IMO. Okay. Okay, so all I want to say here is that because I only have 10-15 minutes, okay, that what you do is, so the choice is obviously that you take C to be origin, okay, but the point is that you have to be a bit smart about it, okay. Like first you have to reduce the problem, okay. So x was some point here, then you can take k here, take L here. Okay, so you have to prove that mk is equal to ml. Okay, so the point is that if you try to calculate m, then like
It's terrible.
it's really bad. Okay, like really bad. So therefore we need to find some way to avoid m. Okay. So
Is it like we just prove the perpendicular bisector is concurrent with AL and BK?
perpendicular bisector of
Of
what?
KL. Of KL.
Of KL. Well, not really. Like you don't want, like concurrency is just terrible to handle usually. Okay.
Oh,
Like in all three coordinates. Like I mean, honestly, trig is the easiest to handle concurrency because you have trig keva. Okay. Okay, so you want to
What about
avoid
vectors?
calculating m.
Vectors
Okay.
can do concurrency easily, right?
Now, can you repeat?
Vectors can do concurrency, right?
Vectors are also bad. Why are vectors easy?
For concurrency.
Not really.
Uh,
Like, how do you intersect vectors, right? Like, it's not clear. Like, if I
Section
give you the
formula?
vector of A, if I give you the vector of L, I give you the vector of B and K, and let's say, some other line, X and some other point. And how do you say that these three vectors are concurrent? Like, the vector from A to L, the vector from B to K, and no, it's not that clear. Okay, so right. So what you do is you consider XM intersection this point. Okay. So let's call it E. Okay. Then my claim is that MK equal to ML
Equals ME?
is some condition on E.
Okay.
E becomes the midpoint.
क्या हो रहा है? ते कूद क्यों रहे हो? So I'm not sure how we could do this, but maybe some sort of trig combination with like the bash to
No,
get
no,
some
no.
sort of combination.
It's Menelaus. Think about
Oh,
Menelaus.
just Menelaus? Okay.
Yeah.
Menelaus in triangle ALB,
Yeah, something like that, if I remember.
or maybe the other one. I'm not sure.
Hmm. Okay. No, it was, Keva. Yeah, it's Keva on triangle AMB. Okay. Where you say that AK, BL, and ME are concurrent. Okay. So that implies that A sorry, not AK. AL by LM into MK by KB into BE by EA. This is one.
And LM equal to MK, then we can just cancel the. If
Yeah,
MK equal M,
so-
then we
Wait, E
cancel.
is the angle bisector. Like CE becomes the angle bisector.
Exactly. Okay. Okay, so this becomes, so therefore ML equal to MK if and only if and AL is, we know, is AC, right? And KB is equal to BC, right?
Right.
So therefore it becomes equivalent to BE by EA is equal to BC by CA. Okay.
Oh yeah, and then C was in triangle AXB, I think. Because
Exactly. Now you get it. Okay. So now the point is that it's still bad. Okay, because
E is in
still
terms of
bad.
M.
Okay. Okay, because E is defined as, right, because E is defined to be,
XM cap.
XM cap BC.
AB.
Sorry, AB. Right. So, and X is bad, I said, right? So
M
E is
is
still
also,
not good.
I think.
But the point is that BE by EA, I can make it to be as a ratio of AK by KX into XL by X.
Oh,
Okay,
Yeah,
by
so C was in the triangle.
It was, yeah. So therefore, BA into AE, BE by EA into AK by K, KX into X, what was it? L by LB. Okay. Yeah. So therefore, enough to show that AK by KX into XL by LB is equal to AC by CB. Okay.
yes.
And this is very doable. Okay. Why is this very doable? Because you can assume that this is some lambda. Okay. And you can assume this is like some 1 by mu. Okay. Because you want to preserve symmetry. Like if you do a calculation with lambda and calculate k, okay, you just want to say that by symmetry, if I replace lambda with mu and a and b, if I interchange, okay, then I get L also.
Right.
Okay. So the point is that now you do a calculation. Okay. So
And now you just have to calculate, for example, K,
yeah,
and you'd be done.
yeah, exactly.
But how do you do K nicely?
Huh?
How do you like compute K nicely?
So you compute it using section formula, right? You assume that X is something.
Okay, we assume X, so fine.
Right. Okay, so
Like we still have to probably do some sort of circle line intersection thing, right? Maybe?
no.
No? Because then how do you handle BC equal to like BK?
Yeah, that's the point. I'll tell you. Okay, so I've linked it in the chat. Okay, so I'll also look at my own chat. Where is it? Okay, so here it is on this page. Okay, so if you look at this, I do exactly what I said. Okay, it's a bit hazy, but maybe I can copy paste it. Okay, so I say that without loss of generality, we take C origin. A is this, P is this. Okay, so I calculate slope of CD. Okay, so CD is y equal to A by B into X. Okay, then X is some BT comma AT, right? And then I assume that BL by BX is some N. Okay, so that's what I took to be lambda just now. Okay, so L is this by section formula. Okay, and similarly K is this. Okay. Okay, so here I calculate circle. Okay, but I don't actually need circle. Okay, I can just equate AL and I can just write that AL square is equal to AC square.
Right.
Okay, I did not actually need some equation of circle or something. Okay. So anyway, so if I do that, okay, I get N. So that's on the next page. Okay. So you get some equation about N, okay, which is right here. Okay. And then, I mean, it was IMO, so I did not want to take any chances. So I did not write by symmetry or whatever. I just wrote the same argument again. Okay. So anyway, so you get what M and N are. Okay. And then you just multiply it with B by A and you get 1. Okay.
Isometry can remove marks.
Yeah, there should not be any problem. Okay. Yeah, this is my contest solution. So yeah, this is my, I wrote this at the IMO. Okay.
So if
A
I
general
write
knowledge.
bisometry, will I lose marks or something?
No, it won't.
No.
That's what I'm saying. I just said that this was IMO and I did not want to take any risk.
It's probably better if you state symmetry about what, right? Just to
Yeah, so you should say something, I guess. But anyway,
I have
okay.
a general question related
Yeah.
to that. So when you give in your papers,
Mhm.
do they give you back a Xerox or do they keep a Xerox?
No, they keep a Xerox and they give you the original.
I see. Okay.
Yeah. Okay. So I have officially run out of time. Okay. So I
we
guess
can have it extended.
I don't want to extend it too much. I'll just spend like 5 minutes talking about complex bash. Okay. So let's talk about complex bash for 5 minutes and then I'll end. Okay. So you can okay, so here instead of having a prominent right angle or something, okay, a prominent circle helps. Okay. To choose to be the unit circle. Okay. Because a lot of calculations are easier with the unit circle. Okay. More than one circles are just horrible in complex bash. Okay. One circle, bad for complex bash. Okay. So you can get around it. But like by using, for example, by using like spiral symmetry or something. Okay. Okay, but usually like one prominent circle is good and more than one circle is not so great. Okay. Right. Now
Also, like it's good for rotations.
yeah, so rotation, any 60-degree angle kind of thing. Okay.
Inversion. Is it good for inversion?
Angles are nice. Okay. Proving concyclicity is not too bad.
How do you do it?
You can look up the formulas.
Is it a nice formula or is it a bad formula?
It's not a great formula, but it's not too bad.
Whether it's nice or bad depends purely
Okay.
on your taste.
So main thing here is that remember to always try to like factorizations are your friend. Okay.
What about inversions? How is inversion on complex?
Huh?
What does that question mean?
How is inversion on complex?
I mean, what do you mean by that?
I mean, how good is it? Is it neat? Is it horrible?
So you just want to write the inverted diagram as a complex number.
I mean, like if you do the invert, if you have an inversion, is that neat in complex? Like is inversion
हाँ
stuff
मतलब
neat?
if you invert around inversion around origin is just 1 over z bar. Like inversion around the unit circle is 1 over z bar. Z going to 1 over z bar. So for any other circle, you can translate to origin and translate back. Okay. So Yeah, so one nice example that I wanted to give was, this is my P1. Okay. Again, I bashed it in the contest. Okay. At the same website, like my WordPress site, I've posted a solution to this also. Okay. Like not just a solution, but like the solution that I gave in the contest. Okay. So, so that, so I basically bashed both the geometries in IMO. Okay. So hence the title of the talk. Okay. And so my teammates actually like were very surprised because they thought of me as like a good geometry person and like a person like a purist or something. Okay. But then I ended up not worrying about it, and I just simply bashed both the geometries and got a nice silver medal out of it. Okay. For my efforts.
But wait, the last problem was P5.
Huh?
The last problem was P5.
So this one was P5 and this one is a P1.
Oh, how come?
Yeah, so
Jeff rule
back
wasn't there at
then
that time.
back then it was a different rule. Anyway,
What rule?
so it's like 1, 2, 4, 5 cannot have like two of the same subject or something. Anyway, so I thank you guys. Okay, so any questions? Okay, then we can end it here. Thanks for.
Okay, then. That was a very good session.
I have a general question, I suppose you could say.
Yeah.
So, what are some key factors to look into a problem to realize, not particularly for different types of bash? So, what you should generally see in a problem to decide what way should go? Should you go for bash? I mean, you've explained that if you should go for bash, which
Yeah, so that's
types?
what I'm saying. Like, for example, here I always knew in the back of my mind that I can bash it. Okay. So because of this 90-degree angle, I was like, I was very sure that I can bash it. Okay. But then when I ended up trying to bash it, then I faced some difficulties because calculating this M is like very, very bad. Okay. And I remember after the exam, I talked to people. For example, the US team had a very tough time with this problem. Like in their team, not a lot of people solved this problem. Okay. And actually, it ended up being the fact that P5 was like one of the tougher problems. Okay. I mean, not tougher than P3 or 6, but like, I mean, tougher than a usual P5 at least. Okay.
So you can't guarantee quite the success of your bash, but there are some small things to look into a problem to realize if you could go for bash or
Exactly.
there's a nice synthetic way to it.
Right. So, yeah. So, in fact, what ended up happening was that I had like a very lengthy calculation on rough. Okay. But like, so what happened was that my rough work is like really, I was very bad at organizing my rough work. Okay. So I could never like present my rough work as it is. Okay. So it took me quite a long time to like write it very nicely and everything. Okay. And yeah, so it took me quite a while to write down this solution. And what ended up happening is that I got P4, but then I ran out of time while writing down P4. And that cost me like 4 marks. And if I had got that 4 marks, then I would have gotten a gold. So yeah. So anyway, it doesn't matter now. But yeah, it makes for a nice story to tell.
So until you kind of explore a problem and then you see, then only then can you decide.
Yeah, to answer your question, it's mostly like if you, I mean, there are some telltale signs, right? Like I said, there's a prominent right angle. Okay. Also, see, the point is that it comes with practice. Like if you practice a lot of problems, okay, and you always try to think even if you don't calculate it out, always try to think it out in your head that is this bashable, okay? And like, yeah, I mean, if you do that enough times, you'll have a feel for what problems are bashable and what are not so bashable, okay? So for example, this P1 is very, very bashable, okay? It's like so easy that it's like almost unfair.
But the synthetic is very cool.
Synthetic is very cool too, I agree, but it's
But
very
in the
easily
moment,
bashable.
what's best in the moment would be coming only after practice.
Well, okay, see, here's the thing. I'll say this. If you have a feel for key, okay, I think I can bash this, okay? So one thing that I will do is that make like a set of steps, okay? So try to map out
Or could we get the
set of
pointers
steps.
at the end of the class, perhaps?
Huh?
Like perhaps could we get the pointers at the end of the class?
You mean this notes that I've made?
Right, yeah.
That's okay. I'll put it. Okay, so yeah, so try to map out the set of steps. Okay, it's like, you know, if you have done any algorithms or something in computer science, okay, you try to map out the complexity of your solution. Okay, like if is it O of n or O of n square or whatever. Okay, but
Kind of like a pseudocode
it's kind of like that, huh? Okay, so you try to, you know, figure out the complexity. Okay, that, you know, this will be this complex, okay? But of course you don't actually figure it out completely until you actually get to it, okay? So yeah, so it's not a perfect thing, but it works, okay? And it works more often than you think, actually, okay? But yeah, so one very key advice for any, you know, complex bash is like always try to factorize, okay? If you want to prove that some a minus b by a bar minus b bar equal to c minus d by c bar minus d bar, okay, don't just calculate this and just cross multiply and expand it out, okay? Because that is not going to be very nice, okay? I mean, not only is that not going to be very nice, it's probably not even doable.
I see.
Okay.
Okay.
So always try to look for factorizations. Like if, for example, c minus d is nice, okay, then you know that there will be this kind of c minus d factor here. Okay, so you try to look for a c minus d factor in a minus b. Okay, I mean, there will be some relations, right? A minus b will be somehow related to c minus d. Okay, so you try to look for that factor here, there. Okay, so like if this is some x square minus yz, then you look for like an x square minus yz factor here. Okay.
Yeah, that nicely answers the question. Yeah, thank you.
Okay, also for trig bash is like, it's very important that you try to think about, okay, so for trig bash, think about trying to construct the figure, okay? Try to think about how you go about constructing the figure, okay? Because see, trig is all about solutions of triangles and stuff, right? So if you can solve the triangle, which means like if you can construct the triangle, okay, then you can figure out each and every length and slash angle, okay? So yeah, so therefore this is like one tip that I'll give you, okay? And like, so this works, and like try to like always be on the lookout for trig KY applications, okay? Whenever you see some kind of concurrency like this, PM and QN, so P and Q very disjoint kind of points, M and N are very disjoint kind of points, okay? But the point is that M is given for P in terms of some angle conditions, right? Like intersection of circles can be thought of some kind of angle condition. Okay. And angle conditions are what you want as in trig keva. Okay. Like trig is good with angles. Okay.
Yeah.
Yeah.
Like trig
like
is just
this kind of
basically to put
basic
lengths
stuff.
into angles and angles into lengths.
Huh. Chalo, I have to run now. Okay, I have some private commitment. So I'll take your leave. All right.
Yeah, sure.
Bye bye.
Nice session. Thank you.
Thanks for teaching.
Thank you, sir.